Okay, last chain rule example for the day. F of x is natural log of x. The derivative of that is 1 over x. We just talked about that in the previous video. What if we had something more than x is that we're taking the natural log of, okay? What if we're taking, instead of the natural log of x, we're taking the natural log of ugly, okay? Well, this is a chain rule again. We have an outside function, natural log, but instead of having x as our inside function, we've got that polynomial right there. So we're going to follow our chain rule process. All right, the chain rule process says derive the outside. Well, the natural log of x is 1 over x, if we look for its derivative. So if we have the natural log of ugly, well, then following the same template, we'll have 1 over, just like we have 1 over here, but here it was the natural log of x, so we put x in the denominator. Here it's the natural log of this polynomial. Guess where this polynomial is going? Exactly, it's going into the denominator. X squared plus 2x plus 3. Okay, so we derived the outside and we kept the inside. We did not change the inside yet. Now it's time to derive the inside. What do we do with it? Well, we multiply by the derivative of the ugly. That's deriving the inside. So we now have to multiply this by the derivative of that polynomial. What would be the derivative of x squared plus 2x plus 3? Yeah, you're old pros at this by now. That's going to be 2x plus 2. Okay, so there's our answer right there. Now you can leave your answer like this, but again, just keep in mind that on the exam they like to just simplify, not simplify, but neaten things up a little bit. If you're multiplying 1 over something by a base level object, they're going to take this and they're going to toss it up in the numerator. So while this answer is fine, just keep in mind that the answer that you would see on the exam would have 2x plus 2 in the numerator and x squared plus 2x plus 3 in the denominator. Okay? One way that I tell my students to look at it in the classroom, if we're asked to find the derivative of the natural log of ugly, the answer will be the derivative of ugly over ugly.